Hello everyone. Today I will share my fifth task with the Spark Foundation, which is traffic sign classification in the field of computer science. First of all, we will import some library such as Matplotlib, TensorFlow, NumPy, and so on. And then we will go with pre-process data. We will define a function called load split, where we will use next in our code. First of all, we will call the path of our data. Uh, we will deploy, download the data into your desktop, and then call this path from your desktop. After that, we will uh, first of all, our data contain SSV file and image. The SSV file contain the image paths and other information about the image like class ID and size and other things. So here we will extract the label and the image path from the SSV file. Uh, which its position, the last and before the last uh, column. That's why we have put minus uh, 2. After we read the image path, we will read this path, resize it, and this exposure equalize adapt this it. Our image has poor contrast. That's why we use this function to improve the contrast of the image. And after we get the image, we will append it into the list called data. And for the label, we will append it into a list called labels. And after this, we'll turn both of them into array using NumPy array, and will be the output of our function. The label that we have put it in the list labels. It's not actually the labels of the sign. It's just the class ID like 4, 5, 6, and so on. But for the real name, the label of the sign, it's in another file, SSV file called traffic signs CSV. It's with the data. Coming with the data, you can download it. And here we have opened the SSV file. This is the path of the CSV file. We will read it and extract the label name. And this is the label that we have in the SSV file. As you can see here, we have speed limit 20 km per hour, speed limit 30 km per hour, and so on. After that, we will bring the path of our training data and the path of our testing data and give it as input for the functions that we have defined before, which is load split, to give us the image and the labels of both of them. After we get it, we will convert it into float 32 and normalize it by dividing it by 255. After that, we take the name of the label um, and transform it into two categorical, using two categorical, which mean we turn it into 0 and 1 instead of string. After that, you can see here the label, as they have said, it's 00 and only 1 for the class, the image. And here we have another function. We defined other function for plotting called plot image. We will give it as input the image and the title of the image. And we have use it here, plot image. We give it the training data as input, and the title will be training X Here, as you can see, our image of the dataset are not clear for the person. That's why we have improved the resolution. This is the training and testing data. This time, we're not gonna use a pre-trained model. We will create our model from scratch. That's why we have add sequential, and we will add our layers one by one, like conf 2D, max polling, conf 2D again, but this time with 64, max polling again, conf 2D with 128, max polling, and finally, we have flatten dance. We will drop some neuron and to not get overfitting. And finally, we have the last layer, which is dance layer with 43, which are the number of classes that we have because we have 43 different signs. After that, we will compile our model. And we will do some with Adam Optimizer, and we will do data augmentation uh, to augment the number of image for our data. And this is the model point summary to display the architecture of our model, the layer, and so on. Those are the layers that we have put, conv to the max polling, and so on. After that, we will feed our model with the training data with 10 epochs and 32 for batch size. And with the validation data, we will put test data. This is the training, and it has given us 0.989 as accuracy. Of course, to be more clear, we have displayed the testing accuracy, which is the same we have got before. It's 0.89 of accuracy. Now we will evaluate our model, and we will do that using the predict method, and we will give it as input to testing data. And this is the result for the 43 classes in terms of precision, recall, F1 score, and support, and of course accuracy, which is 0.90. And now we will plot the result of training. This is the graph where we can see the training and loss and accuracy with the red and purple color and blue, light blue, and the validation loss and the validation accuracy with the blue and purple. And we have notes that the training loss and the validation loss are going to the zero, are around zero, going from 3.5 into zero. And for the training and validation accuracy, it's almost one because we get accuracy around 0.90. And now we will take an image from Google and see an image to test our model. This is the path of the new image. We will read it and do the same thing we have done with the image of our data set, resize, equalize, adapt this for contrast, and normalize it by dividing it by 255 uh, and uh, read the image and add the labels. And after we will put the label using CV to put text. This is we'll put the label into the image, and this is the result. As you can see, this is the blue word is the prediction of the model. Thank you for your interesting, and I hope you enjoy this uh, project.